Hello, and welcome to the Data Engineering Podcast, the show about modern data infrastructure. You can go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. And you can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. There's also a community site at community.dataengineeringpodcast.com where you can join the conversation with other listeners and help out by giving suggestions and feedback. Your host is Tobias Macy, and today I'm interviewing Daniel Whitenack about Pachyderm, a modern container-based system for building and analyzing a versioned data lake. So, Dan, could you please introduce yourself?
Yeah, I'm Daniel Whitenack, as you mentioned. I'm a data scientist and developer advocate with Pachyderm.
And how did you get started in the data engineering and data analysis space?
Originally, back in the day, I started out in physics, eventually decided that I didn't want to stay in academia, so moved into industry, finally kind of landed in this data science and engineering space. I was fortunate to start out at a small company, telecom startup called Telnix, where I had to kind of wear a lot of hats. So I did a lot of data engineering along with doing data science, and I gained an appreciation for, I guess, this kind of end-to-end ownership of a data project. So that's kind of how I got into this stuff and how I developed the interest that I have.
Today we're going to be talking about the Pachyderm project. So I'm wondering if you can describe a bit about what that is and the problem that you were trying to solve when the project was started.
Yeah, definitely. Pachyderm is an open source project. It's under the Pachyderm org on GitHub. And what it does is it provides a system for data pipelining and data versioning. It's a totally language agnostic framework because it's built on containers, as you mentioned, and thus you can build data pipelines with basically any language or framework you like, including Java, R, Scala, Go, or even things like TensorFlow. And the output and input data of these data pipelines on each stage are versioned in data versioning. So we can talk about that a little bit further, but it does some nice things for us. When we commit new data into Pachyderm, we can automatically trigger pipelines, so doing things like streaming and batch analysis. That's the basic overview. Regarding where it came from, the co-founders, Joey and JD, who kind of started things, they ran data infrastructure at Airbnb for a while. They were on that team. So working with Hadoop, they were also the earliest engineers at RethinkDB. So they worked a lot with data infrastructure and basically started seeing that new things like NoSQL databases and Redis and Docker and CoreOS felt really awesome and were great to work with. And things like Hadoop felt a little bit ancient. So the vision in starting Pachyderm was really kind of a reimagining of Hadoop that's built on top of modern tools like Docker and Kubernetes.
And I'm sure I could probably hazard a guess, but where does the name come from?
Pachyderm, the name in general, is kind of this defunct classification of mammals that doesn't really make any sense. It kind of means like thick-skinned mammals like elephants or hippos or rhinos. But being that it kind of refers to elephants, I guess the name Pachyderm originally came from kind of a not so subtle pointer to the elephant imagery used in the Hadoop ecosystem. Because again, this really the inspiration came as a reimagining of what Hadoop would look like in a modern world, I guess.
So what are some of the competing projects in the space, and what are some of the features that Pachyderm offers that would convince someone to choose it over the other options?
There's a couple things. They mostly fit into either the category of data versioning or data pipelining, not necessarily both. So there's some projects like Flocker from Cluster HQ and Infinite, which I think it was this week or last week was just announced that it was acquired by Docker, or even like Get Large File Storage. These projects kind of latch on to the idea of like stateful Docker containers and data versioning. Whereas on the other side, you have projects like Luigi or Airflow that are doing data pipelining things. So in comparison to Pachyderm, I guess the one distinction would be that these things kind of are targeting one or the other of those topics. However, at Pachyderm, we're very passionate about the idea that combining data versioning with data pipelining is really way more powerful than trying to glue something like Luigi onto another framework for data versioning. Basically, that data pipelining is best paired with data versioning. There's this kind of symbiotic relationship between the two in our framework, and really allows data engineers and data scientists to produce workflows that are reproducible, collaborative, and easily distributed as well.
And one of the factors that you call out in the marketing site and the documentation is the fact that because of the integration of the data versioning and the pipelining, it makes it easy to track the provenance of the data. So why is that such an important capability of the system?
There's a couple answers to that question. There's different aspects, or different, I guess I should say, benefits when it comes to data provenance. The first thing is that really, as we build more data pipelines and models and statistical analyses and other things that impacts users directly, we're going to be held more and more accountable to that. And this is already being seen in some like EU regulations that are coming out that basically are telling people that they have a right to an explanation for algorithmic decisions. So one part of data, you can't really give that explanation. And so there's like a compliance element to this, or an auditing element, maybe if you're an insurance agency or something like that. But then the other side of it is that data provenance is really a precursor to true collaboration in an organization. So if I'm developing some nifty model or some analysis or some amazingly efficient pipeline, I'm not working in a silo. And I want people to be able to reproduce what I've done using the same data that I used to produce the same results that I saw. And this isn't really possible at all if you don't have some way of tracking how your data is moving and changing, and some way of pairing that with the actual analyses that you're doing.
And the versioning capability of the data is definitely something that is not as widely used in a lot of contexts, largely because of the fact that, from what I've been able to gather, the primary storage mechanism for distributed data lakes is the Hadoop file system, which I know is based on Java. But what does Pachyderm use as the base layer for being able to provide that versioning capability, as well as the distribution and scaling mechanisms that are used in conjunction with that?
One of the kind of major mindsets that we have at Pachyderm is that we want people to stay focused on their problems and solving these data engineering challenges, and using their expertise to solve these data engineering challenges, and not necessarily having to worry about this file system. So basically, PFS sits on top of any generic object store, like S3 or GCS or Ceph, Swift. And basically what we do is treat this object store like a CDN for data. And along with some smart caching allows us to have this distributed, scalable, and resilient data, along with kind of the solid performance. And because all of this is scheduled on Kubernetes, it means that basically for end users, we can scale up and down arbitrarily to service more requests or add more cache space, for example.
And if I recall properly, I believe that in one of the earlier permutations of the Pachyderm system, it used BetterFS for being able to handle the versioning of the data as well. Is that correct?
It's possible. I'm a recent addition to the team, so I'll have to go defer to my colleagues on that particular one. I know that we've utilized Fuse, although in our most recent release, there's been some changes to that where we actually prefetch some data, not relying on Fuse, which gives some performance advantages.
And the versioning capability of the data, I know, is handled at least partially by tracking the diffs as you apply different manipulations to the data itself. So given that the fact that it is that the current state of the data is computed by applying the various diffs on top of the base state of the data, I'm wondering how that affects the additional storage capacity that's necessary for storing those changes, as well as the performance aspects of the impact that having to apply those various diffs on to compute the current state might have when somebody's trying to do analysis on top of it.
Yeah, that's a great question, and kind of basically getting into the trade-offs of data versioning. But I would say, so Pachyderm definitely doesn't save copies of files in terms of saving the different commits of your data into versioning. We only store the diff, so it's space efficient in that way. And to just give you an idea as far as like the space efficiency in terms of numbers, we store maybe about 64 bytes of metadata per 8 megabytes per an 8 megabyte block of actual data that you're pushing into versioning. So it's pretty space efficient in that way. Also, in terms of like the actual computations, one of the things that's nice is like a Pachyderm job or a Pachyderm pipeline either subscribes to a certain repository of data or is actually run on a specific commit of data. So for each analysis, basically you're analyzing data at a certain state. You're not having to kind of scrub through a history of data commits in order to figure out how to process your data. So on a per job or per pipeline basis, we're processing one commit of data that's coming in, and then we're making one commit of data out.
And for typical use of Pachyderm, would somebody keep all of the revisions of the data in perpetuity, or are the change sets primarily just useful in the context of the analysis workflow, and then the final state of the data would then get merged back into the base layer?
This persistence question is really, I guess, on a case-by-case basis. We've seen some users that do want to keep the whole history of their data. So maybe if you're thinking back to what I said earlier about a insurance company or maybe a company that's like labeling people as fraudulent or whatever it is, it could be that you want an audit trail for your data a good ways back, and so you might be persisting this whole commit history in perpetuity. Other companies, like let's say maybe like a smaller web company that has certain policies around privacy or whatever it is, or maybe they're only concerned about the data for the past 48 hours, they might stream that data in and then basically delete those repositories or those commits afterwards. Or they might have a part of their pipeline that specifically anonymizes and persists only certain data after a period of time. Pachyderm is designed in general to store as much or as little data as you would like to persist. The mechanism is the same around commits and branches. It's just up to you how you'd like to organize and persist it.
And given the versioning capability, is this something that would be feasible to use as sort of a secondary store for being able to keep a historical record of transactions for a primary database for somebody using for instance, Postgres?
Yeah, we've actually seen a couple of uses specifically with Postgres actually in the last couple weeks. Basically, so one use case had to do with a variety of, this series of tables being generated in a pipeline and then dumping those tables into Pachyderm in order to basically have the whole history of those tables that were being generated in Postgres in Pachyderm's file system. So it's definitely something that we see, and it's something that is oftentimes maybe a first step for people as well. So maybe they have this pipeline that's pushing data to Postgres or whatever data warehouse they're using, and they just want the history of that such that they can either revert or such that they can analyze diffs between certain times or whatever it is. This might be a first step in order to kind of start getting into Pachyderm and learn about the versioning is to actually use that as kind of a time machine for your database. But then those companies also, once they kind of get there, they begin to think about, okay, now I have this kind of time capsule for my data. This also allows me to kind of keep my analyses in sync with that with that data over time. And this is what sometimes leads into bringing in the analysis pieces as well.
And what's the typical interface for somebody trying to load their data into the Pachyderm file system, either streaming or in bulk? Is it that they would generally upload it as a batch job to the S3 or Google Cloud Storage, or is there an interface that Pachyderm provides to sort of abstract the backing data store away so that they could just interact directly with Pachyderm itself?
The object store and Kubernetes can be basically transparent to a user. So Pachyderm does provide its own interface to these things, and you can think of it basically very similar to how you interact with GitHub via Git. You have files locally, or you have files somewhere or data somewhere, and you can commit that data to Pachyderm via commits, and you define a branch, and then you can transfer those files or that data. And this could be everything from, some of our users are committing, hundreds of gigabytes at a time into their data repositories, maybe slightly less frequently than other customers who are maybe feeding pipelines off of Kafka or something like that. And they might have a service that basically is just making high frequency commits into Pachyderm, which is then triggering streaming analysis within Pachyderm. So it's everything in there. We have a CLI tool that will let you do these things, manually and inspect things manually, but also you can utilize our Go client. We have a nice Go client, and there's actually other clients in the works as well. There's Rust clients and Python, and actually a REST client in the work that will basically make this kind of interaction universal as well.
And are there any particular data or serialization formats that are better supported in Pachyderm, or is it largely just a matter of the language and tools being used to actually interact with the data once it ends up at the Pachyderm file system? Is there any particular capabilities that the versioning layer adds on top of serialization formats such as Avro or Thrift, or is it largely agnostic to that?
Generally, I would say it's largely agnostic to that. So the Pachyderm file system and the way that your analyses work with it is basically just like you would work with any other file system. So how you interact with version data is the same way that you would interact, via file IO with any other files. So you can utilize whatever libraries, whatever formats you like. There are some interesting features for certain data types. So there's some functionality that's been built in around JSON data, like line-based delimitation of data. And there's other things to possibly be aware of. For example, if you have lines of JSON data and you modify a certain field within one of your JSON blobs, the way that we do parallelization, it might not be, so it might have to process that entire blob instead of rather than just adding a new line where you would only process the new line or the new part of your data. So there's some caveats here and there, but for the most part, it's just generally whatever files you want to use and interacting with them the same way you would with any other file system.
So as you mentioned earlier, another one of the compelling features of Pachyderm is the fact that it can natively support the use of any language for interacting with and analyzing the data. So I'm wondering why that's such an important capability, and what is it about some of the other systems that might make it more difficult to achieve that same result?
This is a hugely important point in my mind, working both with data scientists and data engineers. I've seen that basically everyone comes from a different background. They've used different tools. They prefer different tools. Data engineers are maybe more interested in JVM languages like Java or Scala, whereas some data scientists might have come from a statistics background and work with Mathematica or R, and other ones maybe are like scripting with Python. So there's this whole range of tools and whole range of backgrounds. And so this is really the situation we're in and will be in for quite some time. And I would say that no one really knows the tools that they're going to be using even a year from now. So building up your pipelines in a language agnostic way is hugely important. And also in the sense of bridging this gap between data engineers and data scientists. Again, data engineers We love to think about how something will scale, and might get very frustrated sometimes with scientists who build incredibly inefficient code. Again, one of the nice things about Pachyderm is you're utilizing these very simple file I/O operations to access your data. You can write something simple, whether it be in R or whether it be in Java or whether it be in Python, and insert it into Pachyderm and instantly be able to distribute that and scale it across your data, and also instantly be able to have, your data scientists Python script interacting in this distributed, scalable way with your data engineers parsing and other pipelining stages that are maybe written in Java or Scala. So I think this is hugely important. Other frameworks, for example, like Airflow or Luigi, they might be tied to specific languages. A lot of times you see things tied to Python, which is kind of limiting, especially, as I say, for data engineers that really like JVM languages. And it really doesn't promote the kind of autonomy for individual data scientists and data engineers to be able to say, like, this is the best tool for this situation. I'm going to choose it, and I will be able to deploy it in a consistent way. That's kind of what the Pachyderm philosophy is, like, choose the best tools for these different stages, and we'll deploy them in a very consistent way that will also be reproducible across your data.
So a couple of questions off of that. The first one being, I'm wondering if there are any built-in capabilities for being able to alert on any failures in the data pipeline so that they can be caught and remedied early on. And if there are failures, is it easy to... I'm assuming that it's easy to resume from where that failure occurred because of the fact that it does have that versioning step, so that each step of the pipeline, I'm assuming, is associated with a particular version marker in the file system itself.
Yeah, that's great deduction and very much the way it is. So Pachyderm does have some failure capability built in, including, notifications of failures, but also being able to get your logs from your containers that are running in Kubernetes for particular jobs that are running off of particular commits. But also, like you said, there's this feature that it's maybe a little bit subtle when you start thinking about it, but very powerful when you grasp it. The fact is that, if you have this complicated pipeline with maybe 7 different stages that branches out these ways, and then there's 5 other stages over here and 2 other over here, what Pachyderm allows you to do is, on commits into the input of your pipeline, things will run and maybe something fails, but you don't have to rerun every single stage in order to recreate your result. Because things are versioned, all of those commits to the other data repositories are existing, the successes. So basically what you can do is gain some efficiency by the next run. Once you fix your problem, maybe you fix your image and you update your pipeline, you can run just on that new data, on those stages that need to be run in order to produce your result.
In the versioning of the file system, does it also record any sort of metadata as far as the time that the version was created, so that you can go back and see when a failure happens, you can see when the actual time of the last data commit happened? Because I can see where that would be potentially useful in a number of situations.
Yeah, and this gets to another really great implication, I guess, of data provenance. And by data provenance, what I'm meaning is this data came out, or this result came out of this pipeline, or maybe a stage of a pipeline failed. With things being versioned and with the provenance features of Pachyderm, what you can say is, this series of commits to these series of data repositories were processed by these series of pipelines, eventually leading to the point that you're interested in, whether that be a weird result that you get or whether that be a certain failure in a certain stage. So this also has some really great debugging functionality, because once something fails, you can look at the whole provenance of what went where, what was transformed where, in order to produce the input that is actually input to the stage that failed. And you can look back, and like you said, you can look at the different timestamps of those commits and the different commit IDs, and look at the state of that data wherever you'd like in any series of data repositories that you would like. As well, the pipelines and the jobs have time information about when they ran, when they finished running, and there's some inspecting functionality that's built into Pachyderm there.
And I can imagine that another thing that would be fairly important for being able to properly track the provenance and reproduce the results at various stages of development is having a good way of being able to reliably determine the exact container images that were being used for each iteration of the pipeline. So I'm wondering if there's any sort of integration with a Docker registry or any sort of mechanism for caching the actual container images that were used at various points in the pipeline.
You're definitely right. I mean, you can version your data, but if you don't know what images were paired with that, then you don't explicitly know what the complete story was. There's a couple of points here. So the first point being that Pachyderm will work or can pull images from any Docker registry that you're running, whether that be an internal private registry or Docker Hub or whatever it is. You can pull images from any of those places. Because of that, and because that interaction is just as you would expect with working with a registry, you can make use of tags in order to properly tag your images as far as like which tagged image was used in which analysis. This information will be tracked. As well, there's some nice development functionality related to this because it's very possible that during development you pull an image in a Pachyderm pipeline and then it fails and then you have to correct it. So you have to change the image. And basically, you might not want to keep updating the tag, or it might not be ready for you to tag, your production container yet. But what you can do is utilize this update pipeline functionality in Pachyderm, which will, under the hood, it will pull the latest build of your Docker image, and it will basically create a unique tag for that image and store it in an internal Docker registry. And each time you update, it will do that. So it's basically during this development cycle where you're iterating around the images you're using, you can do that very quickly with this kind of internal tagging.
And given that you're using Kubernetes as the orchestration mechanism for the containers, does it also support the Rocket container image format?
Right now, we only work with Docker containers, which I think covers most cases. There is some conversation going on around that, and I can also provide some links to that and to our Slack channel for more information on that after the podcast.
Yeah, so I'll make sure that all that gets in the show notes. And another question that I had about the pipelining capability and the intent of being able to move the analysis code that's generated by data scientists into the operational pipeline without having to re-implement all the algorithms, because I know that can be a fairly large investment when you're using one language to do the analysis and running the actual production deployment of it in another language. But it also potentially runs into the situation where the analysis code itself, even though you don't have to rewrite it, might not be appropriately scalable to have the necessary performance characteristics. So I'm wondering, what are some of the things to watch out for there, and what are some of the mitigating capabilities that Pachyderm might provide?
In this sense, the way that we distribute our analysis via containers and Kubernetes can be very powerful. Again, as I've kind of switched back and forth from data engineering to data science throughout the things that I've done, I've seen exactly what you've talked about. So this hard transition from data scientists having something they like on their laptops and transitioning that into something that can actually be used in production. A really nice feature of Pachyderm is that Pachyderm can really smartly distribute your analysis across your data, even if that analysis is kind of quote unquote dumb analysis or kind of simplistic without a lot of thought as far as parallelization or anything like that. For example, recent example I was just using basic scikit-learn models, which don't necessarily scale super great, but I was able to do kind of this massive hyperparameter optimization with just these simple scikit-learn models, because I could put simple scikit-learn model in a container, and then I could use Pachyderm to say, spin up 100 of these containers and supply each one with 1/100th of my data, or you could say like supply each one with different parameters for the optimization. And then at the end, we can have a container that reduces these results. And in that sense, your data scientists didn't have to worry about making some model that was out of the box, easily distributed, but they were able to do kind of like their own what made sense in their mind and distribute that easily with Pachyderm. So that's one thing to keep in mind. And that kind of paired with this language agnostic feature allows your data engineers to write very efficient things in Java, Scala, or Go, or whatever it is, and kind of feed that into this distribution of data science tools.
And the integration of the data pipelining and dependency graph is definitely very useful, particularly given the level of integration to the file system and the versioning interface. So I'm wondering if that precludes any requirement for using external tools such as Luigi or Airflow.
Basically, the answer is yes. I mean, again, we're very passionate that the combination of data versioning with the pipelining piece is really what empowers these innovative, reproducible pipelines. And you can define this whole pipeline, whether it's a very simple ETL pipeline, maybe it just consists of one stage, all the way to a very, very complicated pipeline used for research or whatever it is. You can define all of the specification with Pachyderm and pull in whatever images you need and whatever languages you need. Pachyderm provides this way of doing the pipelining, as well as something that Airflow and Luigi kind of don't provide, which is a natural way for you to keep your pipeline in sync with your input data. Because the versioning is there, you know exactly which data has been updated. And so your dependency scheduler should only process that new data.
And in terms of the analysis patterns and sort of algorithmic approaches, I noticed that the documentation mentions the MapReduce pattern, and I'm wondering what other sort of approaches are supported in terms such as streaming or interfacing with tools like Apache Drill.
MapReduce is definitely possible in Pachyderm. I don't think we could be a proper reimagining of Hadoop without some MapReduce pipelines. Developers have flexibility here. So you could have MapReduce, you could have multiple maps, and you could have filters. You could have a single non-parallelized pipe where you're basically utilizing the data versioning capabilities maybe to do some ETL. Some of our users are doing just that. They're processing log lines with a Pachyderm pipeline to parse values out or format output, or maybe process web-related events. Pachyderm is a natural fit for both streaming and batch processing. And once you start kind of thinking about this data versioning combined with analysis mentality, really the issues of whether something is streaming or batch to some degree disappear, because we have users that are doing quote unquote streaming with Pachyderm because they're making very high frequency commits into data versioning, and those high frequency commits are triggering pipelines in a streaming fashion to process all of those commits, those events coming off of maybe a message queue, maybe Kafka, and process that, while other users are doing very quote unquote batch things where they're maybe making a commit of a large amount of data daily and doing some aggregation or driving a dashboard or whatever it is. So yeah, all of those scenarios are covered. One of the challenges in kind of starting with Pachyderm is because there's so many possibilities with those, sometimes it can be hard to think like, what should I start with? But I would say, for those that are interested in these just more straightforward ETL things, that's kind of where you should start with Pachyderm. And maybe for those looking to do distributed MapReduce, we have examples of that too. And all of that's in our docs.
And speaking of getting started, what does the deployment story look like for somebody who wants to start experimenting with Pachyderm, either locally on their laptops or in a production context?
Locally, it's very easy. Kubernetes now has this Minikube program. So basically, you can use that to deploy Pachyderm within, I think 3 commands now, and I think we're getting rid of one of those commands fairly soon. But basically, you have to deploy Minikube, and then you run pack control deploy and to deploy your Pachyderm cluster within Minikube locally. And that's actually how I do a lot of development work too. I'll just have Minikube running on my laptop and develop my pipelines in that way. So that's another really good use of that. But then also we have deploy scripts as well and instructions for how to deploy on Google or Amazon and Azure. Most of the time, if there's any issues, it might be in spinning up your Kubernetes cluster. And once you have your Kubernetes cluster up, deploying Pachyderm again is just like deploying a Kubernetes application. So if you have Kubernetes up in your respective cloud provider, or if you can get it up, then that next step to Pachyderm is very straightforward.
And what are some of the most interesting or unexpected uses of Pachyderm that you've seen?
That I really like, coming from a physics background especially, is our work with General Fusion. So General Fusion has probably been, I think, the most interesting and longest running uses of Pachyderm. They're the company that are designing the world's first full-scale demonstration of a fusion power plant. So it's pretty cool stuff. Some of the things that they liked about Pachyderm were, one, the language agnostic piece, which allowed them to not have to worry about rewriting their whole tech stack, and also this data versioning piece. So they had a bunch of different research teams that were working on various things. They would pull down, before Pachyderm, they would pull down things onto their laptop and work on their analyses, but inevitably those analyses would fall out of sync with their latest calibration. So this has basically eliminated that kind of frustrating cycle and allowed them to collaborate in a more sane way. Another project that I'm pretty excited about is a project with one of the major newsrooms that we're working on right now, and basically building a time machine for a comment thread. So as we all know, comment threads on blog posts or Reddit or wherever it is can get a little bit hairy. So what we're trying to think about is building a way for moderators to basically have time snapshots of what a thread looked like at various stages in the past. So that's like this data versioning piece, as you can imagine. But then on top of that, we can pair the different snapshots with different statistics and aggregations of metrics for those different times. So like we could use NLP, for example, to get sentiment for various users at a certain time window and that sort of thing. Those are the ones that I'm definitely enjoying watching right now.
And building something like Pachyderm is certainly a fairly time-consuming process, and I'm sure that you and everybody else who you work with isn't doing it for free. So I'm wondering what the business model behind Pachyderm looks like.
Right now, I think we're 8 people in total. I mean, everybody's an engineer, really. We've focused a lot of the time until now on building the core platform, but kind of the business model around that and something we're already seeing is that, along with other open source projects that are out there that are actually backed by some business entity, people love open source because they can dive right in and they get everything for free, of course. And we provide a great community around it, and including, a Slack team and all of that. And there's a lot of open discussion about it. But as well, a lot of enterprise users want a little bit more hands-on support. So providing that engineering support to them and support in general is one way to bring in those funds that are kind of powering the development.
So what are some of the areas that you're looking for help from the community? And are there any particular issues that the listeners can check out to get started with the project?
We are really looking for 2 things right now. I mean, users and contributors, that's the 2 big ones, right? We're definitely wanting users to come online, join our Slack team, which you can find on our website, pachyderm.io, and basically discuss with us, what are your use cases? And like I said, we are very, very much wanting users right now. So if you come on there, our whole engineering team will be very quick to respond to you and help you get your toy model up, and then a prototype and maybe a POC. Will help you all the way along that road. And that's really helpful for us because along that road, we get feedback about kind of little kinks in workflows. So everyone has a slightly different workflow that they'd like to see, and figuring out trends in where people are getting stuck, that's really helpful to us at this point. So anyone who's even slightly interested, I would encourage you to get online and just try out a few things, give us some feedback, and that would be much, much appreciated. On the contributor side, there's definitely a lot of open issues online. In the past, we've tagged quite a few noob friendly, I think, for new contributors that want to start contributing. I'm not sure the current status of how many of those there are, so that would be one thing to look for. But if you're not finding those, I would encourage you, some initial things that would be really helpful is, we put up all this documentation and just kind of going through each of the examples and doing two things. So fixing any documentation errors is obviously helpful, but also as you go through these different examples, everyone has a different setup on their laptop, or they're deploying to maybe a different cloud provider or whatever it is. So as you're going through those examples, you're also finding potential bugs or maybe issues with our deploy script. And those are things that you can kind of hop on our Slack channel, see if anybody's experiencing the same thing, or look through the issues, see if it's been brought up, and then bring up those issues and maybe even address them as well.
And what is the language or languages that Pachyderm is actually implemented in so that people who are familiar with those languages can go ahead and check it out?
Yeah, Pachyderm is written in Go. So that's primarily the language that you'll find throughout the repository. And if you're wanting to contribute, although we are in the process of doing some front end things as well, as far as the UI is concerned. If there's interest on that side as well, that's definitely something that we're exploring.
So are there any other topics that we should cover before we close out the show?
No, I think that covers most things. It was a good discussion.
Great. So for anybody who wants to keep up to date with you and the project and get in touch, what would be the best ways for them to do that?
You can find me online. I'm DWhiteNA on Twitter. And also regarding Pachyderm itself, I mentioned our website, pachyderm.io. Make sure and check that out. And on the website, there's links to our GitHub and our Twitter and our Slack. Even if you're just experimenting or playing around with the examples, it would be great. You can join our Slack channel and just have some basic discussions with us about Pachyderm. So that's a great way to get connected. And various of us are also on Gopher Slack if you're a Go programmer or maybe a potential contributor and want to talk to us there. So.
All right. So as an aside, this is the first interview I've recorded for this podcast, so I'm currently trying to figure out a good sort of closing question to ask all of the guests. So some that I'm considering are, what's your favorite data set? Or if you had a free weekend, what sort of analyses would you do? Although given that it's a data engineering focused podcast, I'm not sure that those kinds of questions would be the appropriate focus. So I don't know if you have any suggestions.
I think the free weekend one is a pretty good one. I mean, it could be phrased not only in terms of analysis, but in terms of your side projects or what you're involved in with the main project. What would you tackle on a free weekend that you can't get to this next week,
Okay, that's a good one. I'm sure I'll probably go through a few permutations of it, but
yeah.
Let's go with that one.
All right, sounds good.
Okay, so if you had a free weekend to spend working on anything either related to Pachyderm or not, what do you think you would be spending it on?
Well, there's a lot of things in the queue, but I think if I was to have to choose, I would work on my side project, Gopher Notes, which is the Go kernel for Jupyter notebooks. And the one thing I'm wanting to implement in that, which I think is a major feature that needs to be there, is inline plotting in the notebooks. And that's probably what I would work on.
Well, I really appreciate you taking the time out of your day to join me and talk to me about the work that you guys are doing at Pachyderm. It's definitely a very interesting project, and it seems to be solving a lot of important issues for people in the data engineering and data management space, as well as people doing data analysis to potentially make it easier for them to manage their own pipelines. So certainly something I'll be keeping an eye on, and I'm sure that a number of the listeners will be interested in taking a look at it once they hear a bit more about it. So thank you again.
Yes, and thank you for the opportunity. It was a great time.